is 15. 15 is, you make the denominator 2 minus 1 by 2 factorial, 3 minus 2 by 3 factorial, 22 minus 1 by 22 factorial, 1 minus 1 by 2 factorial, plus 1 by 2 factorial, 1 minus 1 by 22 factorial. All this will be eliminated, right? First and last. So this will be 22 factorial minus 1 divided by 22 factorial. These both are consecutive numbers, sir. Consecutive number 3 divided by 2, what is the remainder? 1. 5 divided by 4, 1. This divided by this, what is the answer? 15 over. 15 is a pretty easy question. 15 over. Devarshi, any doubts? Question number 1 to 22. Which question? Okay, 9th we have not solved.
Sir,
I think.
You
Huh?
get 80.
80 only? 80 only. Right? So I think I am going with Ravi's answer. Anyway, the 341 is not there.
So we can take 3 at a time and.
No, what Ravi is saying is 999 is 37 into 27. 37, 27 divisibility rule is start from the rightmost.
Like 10 cube by 99 is 1. No? So you can take 3, grouping into 3 terms.
No,
340
that is
terms.
That's what I am saying, the same thing. Right? Now, 10 power 3 by 37 is 1, 10 power 3 by 27 is 1. Start from the unit digit, take a group of 3 digits and add it. Question number 1 to 22. Any doubts? Question number 1 to 22. Any doubts? Any doubts? 1 to 22. Snigdha, any doubt?
This digital something will work only for 9.
Multiples of 9 or 9.
Only for 9.
Right? Now let us not, in decimal system digital sum is for 9. Listen carefully to this statement. In base system k, digital sum will work for k minus 1. In base system 7, digital sum will work for 6. In base system 5, digital sum will work for 4. In base system k, digital sum will work for k minus 1. Digital sum, digital root, all are synonyms. There is a very, very subtle difference between digital sum and digital root. We will wind up after this one. See here, digital sum is defined as sum of the digits until a single digit is obtained. This is a digital sum. Another definition for digital sum is a remainder when you divide a number by 9. When you divide a number by 9, you will get the reminders 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 is replaced by 0. That is the only difference. Digital sum is defined as sum of the digits until a single digit is obtained. Digital sum, another definition is divide by 9 and write down the remainder. Wherever 9 is there, I will write 0. That is the only difference. But when you define the question, how many, see here, how many 3-digit numbers will have digital sum even? If I use a digital sum even. Am I right? Listen carefully. 1, 2, 3, 4. 4 even, 5 odd. Yes or no? If I use this definition, 2, 4, 6, 8. How many will be odd? 1, 3, 5, 7. How many will be odd? 4 odd, 4 even. 0 is neither even nor odd. So depending upon the usage, answer also may change. 0 is neither even nor odd. Right? Now, good that he is said. See here, proof. 6 is even. 6 is even. That means even number should be divisible by 2. 2 is a factor of 6. 12 is even. That means 12 should be divisible by 2. Remainder 0. If 0 is even, 0 should be divisible by 2. How can a factor exceeds the original number? You take negative remainder, positive remainder, or you discover a new remainder. but a factor cannot exceed the original number.
Yes.
But sir, 0, 2 zeros are 0.
0 cannot be divisible by 2. Now, I am giving you, those of you who don't know, you should download a book by name, The Number Called Zero. This is the name of the book. Some centuries before, Indians found out that non-existing number is known as zero. There is a section of people, there are tribal people who came to know that non-existent number is equivalent to zero. They took their knives and killed themselves. There is a section of people who killed themselves because they don't want the coming generation to know that non-existent number is defined as zero. Beautifully portrayed in the book, The Number Called Zero. Download the book and read the book and give me the review by morning 6 o'clock. Right?
So you will get to question how to find
1
the
minute.
exact number.
He should be 100% convinced. What he said, now listen. What he said is what is written in one book. In books, it will be written that, please listen carefully, I can understand from which viewpoint you are coming. 0 is even, minus 2. Minus 2 is a prime integer, not a prime number. Minus 5 is a prime integer, right? When you are defining a prime number, you are defining under the set of natural numbers. 0 is neither even nor odd. But in some textbooks, 0 is even. That is only when you are writing GMAT exam. Graduate Management Admission Council asks everyone to consider 0 even. In GMAT exam, 0 is considered to be even. It is written in the GMAT book. Right? So in GMAT examination, you are right. Right? You take a glass, it is half full. You say it is half full, I say it is half empty. Narendra Modi will say it is half air. Anil Nair will say, thank God there is a water bottle. Right? Or some physicist might say, right? If it is half full, you require another 300 ml to make the glass full. Right? Another person will say, another 0.01 ml of water will make the water go to the right outside the bottle. It all depends upon the way you look at it. Are you all with me? 0 is even under the context of GMAT examination. Now it's good that he said 1 comma 1 comma 1 comma 1 comma 1. Is this in arithmetic progression? It is in arithmetic progression because in India we consider B0 to be in arithmetic progression, R1 to be in geometric progression. Suddenly you should ask me a doubt. Sum of infinite terms in GP is A by 1 minus R. If R is 1, the denominator will be 0. That is the reason in the definition mod R is less than 1. It is written that A by 1 minus R, mod R is less than 1. 0 is even in the context of GMAT. In CAT examination, 0 is neither even nor odd. We have got some standard textbooks, NCERT, CBSE and ICSE. Americans have got another textbook. In that textbook, they will call it as 0 is even.
So y equals to 0 represent what?
Y equivalent to 0 is a constant function.
I mean it represents the x-axis.
No, exactly.
So x-axis.
X-axis is right.
So it is symmetry to the y-axis.
Exactly.
So it is an even.
You are confusing with an even number and an even function.
Actually, it is a constant function.
Constant
All
function.
the constant functions are even numbers.
That is saying that for any input of x, y value will be a unique value that will be 0. That is nowhere related to whether it is an if. You download that book, Number Called Zero. Okay? Morning 6 o'clock, give me a review of that book. Right. Please go through the problem. Someone asked me a doubt.
So this can get question how to find out the
28. 2 power 28 minus 1 factors are 2 power 7 minus 1, 2 power 7 plus 1. 127, 129. Answer is 256. Right. Any other doubt? So again we will catch up tomorrow at morning 6:15. We will complete circular tracks and we will also complete this sheet. Ajay, immediately put a WhatsApp message. Right? Morning 6 o'clock, you promised me that you will complete number system assignment. How many did the assignment except Sean? Only reminders is there. Very good. Pradeep. In any way, after 2 months, these reminders, assignment will not come. Till the time you write the exam, only these things. After that, will you use reminders in your life? Right? When it is required, please use it. Otherwise, anyway, you will throw apart Euler theorem, Fermat theorem, time, speed, and distance, and everything. Anyway, you will not use it. Right? First question. Reminder 1. 41 factorial whole square divided by 83. 41 factorial whole square divided by 83. Now, before solving this problem, let us take some important properties. P minus 1 factorial divided by P. It is always P minus 1 if a P is a prime. Just a recap of what we discussed in our class. P minus 2 factorial divided by P. It is always 1 when P is a prime. Reminder 1. P minus 3 factorial divided by P. It is P minus 1 by 2 whenever P is a prime. These are some important key points with respect to Wilson's theorem. Now what I will do is, because 83 is a prime number, so what I will do is, I take the second one. 81 factorial divided by 83 is 1. Second property. 81 factorial can be written as 1 into 2 till 41 into 42, 43 till 81 divided by 83. It is 1. 1 into 2 till 41. It is 41 factorial. 42 divided by 83. 83 ones are 83. Negative remainder minus 41. 83 ones are 83. So it is minus 40. 81 by 83 minus 2. When you further divide, answer does not change. 2 to 41. There are how many numbers? 40 numbers. 2 to 41. 41 minus 2 plus 1. 40 negatives are positive. So 41 factorial whole square divided by 83. The answer is 1. Answer is 1. (41 factorial whole square divided by 83). These are some important key points. 41 factorial whole square divided by 83. It is not always, please do not draw any conclusion that if it is P minus 1 by 2 factorial whole square by P, it is always 1. No, it depends upon the question. (41 factorial whole square divided by 83). This is the first one. 42 divided by 83, 83 ones are 83, minus 41, minus 40 like that. Please try to solve a question. 8 factorial whole square divided by 70 based on this. Next one. Try to solve this question. Shall I erase? 8 factorial whole square. 8 factorial whole square divided by 17. 8 factorial whole square divided by 17. So this will be 15 factorial divided by 17 is 1. 15 factorial will be 1 into 2 and so on up to 8. 9, 10, 11 and so on up to 15 divided by 17. It is 1. This entire number is 8 factorial. 9 by 17. 17 ones are 17. Minus 8, minus 7 till minus 2 divided by 17. It is 1. 2 to 8, there are 7 numbers. 7 negatives will be negative. Minus of 8 factorial divided by 17 is 1. So 8 factorial divided by 17, it is minus 1. Negative remainder minus 1. Positive remainder 60. Just to tell you that for all these kind of problems, answer is not always 1. Answer is not always 1. Clear? Next, write down note. We'll discuss all conceptual problems first. Clear, right? Next. Now. Next, note. See here, note. First question. First concept, N1 is given by H into K1. N2 is given by H into K2. K1, K2 are coprimes. K1, K2 are coprimes. N1 and N2 are any two natural number. H is the HCF of N1 and 2. Now, we'll do all the problems based on this. HCF of A comma B is 6. A plus B equivalent to 60, 360. How many values A comma B can take? How many values A comma B can take? It's an unordered pair. That means A comma B is equivalent to B comma E. HCF of A comma B equivalent to 6, A plus B equivalent to 360. How many values A comma B can take? Now, see here. HCF of A comma B is 6. Can I write it as A as 6K1, B as 6K2? K1 and K2 are coprimes. K1 and K2 are coprimes. So if I add 6 into K1 plus K2 equivalent to 360. K1 plus K2 equivalent to 60. What are K1 and K2? Coprimes. In how many ways can you write a number as a sum of two coprimes? In how many ways can you write a number as a sum of two coprimes? It is given by quotient of n by 2. Quotient of n by 2. 60 is given by 2 square into 3 into 5. Quotient of 60. How many natural numbers are less than or equivalent to 60 and coprime to 60? Out of any two consecutive numbers, one number will be divisible by 2. One number is not divisible. Out of three consecutive, one number is always divisible by 3. How many are not? 2. Out of 5 consecutive numbers, one number is divisible by 5. How many? 4. 6 5s are 30. These 2 2s are 4, 4 4s are 16. 16 by 2, 8. In how many ways can a number be written as a sum of two coprimes, which is given by quotient of n by 2? Quotient of n by 2. Now you think like this, you will get it. K1 plus K2 equivalent to 60. What is the first case? Sum of two coprimes. K1 can be 1, K2 can be 59. 1 and 59. What is the next case? 3, no. 3 and 57 not possible because both are divisible by 3. Right? Next, 7 and 53. Like that, instead of counting it, right? Count all the numbers which are less than or equivalent to 60 and co-prime to 60. Quotient of n, it is nothing but number of natural numbers less than or equivalent to n and co-prime to n. Number of natural numbers less than or equivalent to n and co-prime to n. Co-prime to n. This is one way of asking. HCF of a comma b equivalent to 6, a comma b. Reverse will also be true if it is an ordered pair, it is an unordered pair. Next question. Delete this a plus b into 360, write down a into b equivalent to 3600. Next question. In how many ways can I write a number as a sum of two co-primes? It is given by quotient of n by 2. Quotient of n by 2. Shall I move to the next question? Next one. A into b. A into b equivalent to 3600. How many values a comma b can take? How many values a comma b can take? Again, it is in unordered pair. These concepts related to co-primes are very, very important, sir. HCF of a comma b equivalent to 6, a into b is 3600. How many values a comma b can take? Same concept. A will become 6k1. B will become 6k2. So this will become 6k1 into 6k2 equivalent to 3600. k1 into k2 equivalent to 100. Now see here, what are k1 and k2 here? Co-primes. Now it's a very, very important point. k1 and k2. In how many ways can you write a number as a product of two co-primes? Sum of two co-primes over. Now product of two co-primes. Product of two co-primes. Product of two co-primes. Sum of two co-primes is given by quotient of n by 2. Product of two co-primes. Side heading write down. Number of ways. Number of ways of writing a number. Number of ways of writing a number as a product of two co-primes. Number of ways of writing a number as a product of two co-primes. Number of ways of writing a number as a product of two co-primes. We'll discuss that concept, then we'll solve 2 to 3 problems. Sum of two co-primes we discussed. Now we are discussing product of two co-primes. Now see here. Suppose for example, if I take 72. 72 if I write down in unordered pair, 1 into 72, 2 into 36, 3 into 24, 4 into 18, 6 into 12, 8 into 9. Unordered pair. Unordered pair. Reverse is not possible. 1 into 72, 2 into 36, 3 into 24, 4 into 18, 6 into 12, 8 into 9. Now listen carefully. 72 is 2 power 3 into 3 square. I need to write the number as a product of two co-primes. Now if you see, if I put here 2 power 0, this can be 2 power 3 into 3 square. 1 and 72 are co-prime to each other. So I placed the lowest power of 2 this side, remaining everything I kept this side. Let me take the next power, 2 power 1. 2 square into 3 square. Both are even numbers. Even numbers cannot be co-prime to each other. If I take 2 square, 2 power 1 into 3 square. Even numbers cannot be co-prime to each other. If this is 2 power 3, this will be 3 square. That means only two cases are there where they are co-prime to each other. Even, both are multiples of 3 or both are, right? That means if you observe this into this, can I say this place is either taken by the lowest power of 2 or the highest power of 2? Yes or no? Or if I do the reverse, this place can be taken by either the lowest power of 3 or the highest power of 3. That means this place has got how many choices? Either the lowest power or the highest power. How many choices? 2. This place, reverse, ordered pair. This place either the lowest or the highest. That means what will be the answer? 2 square. For an ordered pair. Unordered pair is half of the cases are eliminated. What will be the answer? 2. Or if you think like this, suppose lowest, highest, how many cases? 2 cases. Like that. If there are 2 prime bases, it is 2 square. 3 prime bases, it is, right? 2, either it will be 2 power 0, 2 cube, 5 power 0, 5 cube, 3 power 0, 3 power. Number of ways of writing a number as a product of 2 co-primes is given by 2 power p minus 1 in terms of unordered pair. Please write down. Why 2 power p came? The place can be taken by either the lowest power or the highest power. Middle value is not possible. Lowest, highest, lowest, highest, lowest, highest. Lowest, highest, lowest, highest. Like that, keep on multiplying and take the half of the cases. I hope the proof is clear. Number of ways of writing a number as a product of 2 co-primes is given by 2 power p by 2 if it is an unordered pair. If it is in ordered pair, it will be 2 power p. I am removing half the cases because half the cases are the nothing but a comma b, another is b comma a.
What is P, sir?
P is the count of the prime bases. P is the count of 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 prime bases. Number of ways of writing a number as a product of 2 co-primes is given by 2 power p minus 1 if it is an unordered pair. 2 power p if it is an ordered pair. I hope it is clear. Unordered pair, ordered pair. Now please let's get back to the question. What is value? 2 power p minus 1. Now what is the value we got? K1 into K2, how much we got? 100. 100 is nothing but K1 into K2 is 100. 100 is 2 square into 5 square. Answer is 1 by 2 into 2 square. Answer is 2. It is mentioned in the question it is an unordered pair. If it is an unordered pair, then it is 2 power p minus 1. Next, 2 more questions. Please write down. In how many ways? In how many ways? 510, 510. In how many ways? 510, 510 can be written as product of 2 co-primes. In how many ways? 510, 510 can be written as product of 2 co-primes. Product of 2 co-primes. See here. It is ending with 0. So it is divisible by 2. 5 plus 1, 6, 6 plus 6, 12. It is divisible by 3. It is ending with 0. It is divisible by 5. Take a group of 3 digits. Plus minus. 510 minus 510 is 0. That means it is divisible by 7, 11, 13. 51 is divisible by 17. All over. 1, 2, 3, 4, 5, 6, 7. it is 2 power 7 if it is in ordered pair. 1 by 2 into 2 power 7 if it is an unordered pair. If variables are present in the question, I will use ordered pair. If variables are not present in the question, I will make use of unordered pair. Please write. If variables are present in the question, it is ordered pair. Variables are not present in the question. Answer is 2 power 6, which is 64.
How are you ending with 17?
17. 51 is divisible by 17.
No, they can be other factors
No,
also.
if you look at 17, if you decompose, what you will get? 17 into 30, 30. 30, 30 contains 2, 30, what are the factors? 2, 3, 5. 2, 3, 5, 7, 11, 13, 17. One more question. A into B. Sum of two coprimes, product of two coprimes. Clear? Variables are present, it is ordered pair. Variables are not present, it is unordered pair. Shall I go ahead? Now see here. Please write down a question. A into B equivalent to 100 factorial. HCF of A comma B equivalent to 1. How many values A comma B takes in ordered pair? A into B is 100 factorial. HCF of A comma B equivalent to 1. How many values A comma B takes in ordered pair? When I say HCF of A comma B equivalent to 1, that means we are writing the number as a product of coprimes. 100 factorial. From 1 to 100, how many prime numbers will be there? 25 prime numbers will be there. 2 power something, 3 power something, 5 power something. Okay. A1, A2, A3, and so on up to 97, 820. In how many ways can I write a number as a product of two coprimes? What will be the answer? 2 power 25. Because it is an ordered pair, I am not dividing it by 2. Answer is 2 power 25. Now, from 1 to 100, there are 25 prime numbers. From 1 to 100, there are 25 prime numbers. From 1 to 100, there are 25 prime numbers. I think if you see, clear, right? Sum of two coprimes, product of two coprimes. See the 60th question present in the sheet. 60th. There is one concept, sum of two coprimes, product of two coprimes, all the possible problems. 60th. Find the number of natural numbers which are coprime to, which are coprimes to 3 power 4 into 5 square and less than. That means HCF of A comma 3 power 4 into 5 square is 1. How many values A can take? How many natural numbers are less than 3 power 4 into 5 square and coprime to 5 square? This is nothing but what is this value? This is nothing but a quotient of 3 power 4 into 5 square. Quotient function is number of natural numbers less than this number and coprime. So this will be the number 3 power 4 into 5 square. Out of every 3 numbers, one number will be divisible by 3, 2 are not divisible. Out of 5 numbers, one number will be divisible. How many are not? This is the answer. This is nothing but quotient function is given by number of natural numbers less than or equivalent to n and co-prime to n. Number of natural numbers less than or equivalent to n and co-prime to n. And co-prime to n. And co-prime to n. Idea clear, right? Silenting right now. Find the number of. You calculate it, whatever answer you will get, that itself is the answer. Find the number of integral solutions. Find the number of integral solutions for the following. Find the number of integral solutions for the following. I hope it is clear, right? Find the number of integral solutions for the following. Now, first question, 1 by x plus 1 by y equivalent to 1 by 10. Next one, 2 by x plus 3 by y, 1 by 6. Third one, 1 by root x plus 1 by root y equivalent to 1 by root 20. Fourth one, in the sheet there is a question, 3 by a minus 2 by b equivalent to 1 by 15. What are a and b? A and b are integers. A and b are integers. First two are very straightforward questions. 1 by x plus 1 by y, 1 by 1, 2 by x plus 3 by y, 1 by 6, 1 by root x plus 1 by root y. Now, to solve this kind of questions, there is a direct notation. If the equation is of the form a by x plus b by y equivalent to 1 by c, it is nothing but x minus ac into y minus bc equivalent to a into b into c square. Not abc whole square, a into b into c square. This is derived after taking the LCM of xy. Please write down this. If the equation is of the form a by x plus b by y equivalent to 1 by c, it can be written as x minus ac into y minus bc equivalent to a into b into c square. Don't waste your time in taking the LCM. 1 by x plus 1 by y equivalent to 1 by 10. This is nothing but x minus ac, y minus bc equivalent to a into b into c square. So this will become x minus 10 into y minus 10 equivalent to 100 is 2 square into 5 square. 2 square into 5 square. Suppose for example, if you see here, 12 is nothing but 1 into 12, 2 into 6, 3 into 4. 4 into 3, 6 into 2, 12 into 1. 12 is 2 square into 3 in power 1. What is 3 into 2? 6. 6 cases, 1, 2, 3, 4, 5, 6. So if I write like this is nothing but a number of factors. So what will be the number of factors here? 3 into 3, 9. This is when positive is multiplied with positive. Similarly, negative is multiplied with negative also, I get positive. Yes, sir? That means, what will be the answer? 3 into 3 into 2. I will get, right? If I take one case, suppose for example, minus 10 into minus 10. x minus 10 is minus 10. What is x value? 0. Y minus 10 is minus 10. What is y value? 0. X and y are zeros. X and y are there in the denominator. It cannot be zeros. Subtract a case. What will be the answer? 70. Please write. 1 by x plus 1 by y equivalent to 1 by 10. This will directly become x minus 10 into y minus 10 equivalent to a into b into c square. A into b into c square. So 2 square into 5 square. Number of ways of writing a number as a product of two positive factors is 3 into 3, 9. Positive into positive, positive. Negative into negative also positive into 2. But there is a case where x and y's are taking zeros. X and y are there in denominator. It cannot be zeros. It cannot be zeros. I hope similarly you can tell the answer for second one orally. Second one. Second and fourth try to solve. Second and fourth. Clear, right? Second one. Two by x plus 3 by y equivalent to 1 by 6. X minus AC, y minus BC equivalent to a into b into c square. This is 6 cube. 2 cube into 3 cube. 4 into 4. Negative into negative. A case where x and y. What will be the answer? 31. Directly will get the answer. This one is the case where minus 12 into minus 8. X is becoming 0, y is becoming 0. Clear? Fourth one. Fourth one also you can solve it directly. Only thing is that plus 1 by b, this b value will become minus 2. That's the only difference. X minus AC, a minus 45, b plus 30 equivalent to a into b into c square minus 6 into 15 square. You can solve it, right? Yep, clear, right? 1, 2 and 4. Now 2 minutes time. Try to solve third one.
By 2 is the number of ways in which it can be written as product of.
That is when the variables are not there.
Okay.
Now variables are there.
There.
Suppose if minus is there, you write it down it as 45 minus A into 30 plus B equivalent to 6 into 15 square.
So here it will be number of factors minus 1.
Right. So this will be 2 into 3 into 3 square into 5 square. This will be 3 cube into 5 square into 2 power 1. 4 into 3 into 2. Here you are asking whether doubling will be there or not?
Again, one more doubling will not occur, right?
No, these positive. Positive into positive, negative into negative. A and B are integers. One can take negative, another can take positive. Sir?
So answer is 23 or 47.
Suppose if the question is 5 minus A into 3 plus B equivalent to 12. 1 into 12. 5 minus A is 1, 3 plus B is 12. A will be 4, B will be 9. 12 into 1. A will be minus 7, B will be minus 2. Both are happening, right? If I take minus 7, 5 into minus of minus 7, 12. 12 into 1, 12. A is 4. 3 into how much it is? 1 into 12. Both are happening. 20 minus 4 root of 5x divided by 20x. This is an integer, this is an integer, integer, integer. This should be an integer. Under root 1, 5 is there. Can I say x will be of the form 5a square? Similarly, if I put 1 by root x, wherever y is there, x will be there. Wherever y is there, x will be there. I will get 5y. Y will be is nothing but 5b square. So this is nothing but 1 by root of 5a square plus 1 by root of 5b square equivalent to 1 by 2 root 5. 1 by a plus 1 by b equivalent to 1 by 2. Now you know how to sum. A minus 2 into b minus 2 equivalent to 4. 1 into 4, 2 into 2. Right? Even if you get a value plus or a value minus, on square I will get only one output. Be careful. Please. Now it's very easy. By looking at the question itself, you can say 1 by root x plus 1 by root y. It is nothing but 1 by 2 root 5. Because root 5 is irrational, delete it. Write down 1 by a plus 1 by b is 1 by 2. That's what we wrote.
If you make it into another form.
And similarly, root x plus root y is root 63. What will be the final answer? 63 is a 9 into 7. So directly it is 1 by a plus 1 by b is 1 by 3. Please put a star mark on third question. Integral solutions. Clear, right? Next. Write down this question.
This is 5, right?
Which one?
For this one. 1 by root x plus 1.
No, you find it out. What is the answer? Here a is 3, b is 6. A is 3, b is 6. A is 4, b is 4. If I take a reverse, 4 into 1, a is 6, b is 3. You take minus 1 into minus 4. Check it out, what are all the values. Now once you get it, then decompose is very easy. Next. Please see the sheet. One question which we did not solve is question number